Hello. Today I'd like to talk to you about low pressure plasmas, atmospheric pressure plasmas, and high pressure plasmas. So this is Ask Me Anything, and today I'm answering a question again from anonymous comment 5722. Hi, welcome back. Anonymous asked me a bunch of questions. Most of them I answered in the chat, but one really deserves attention, I think. I didn't realize that it's not often discussed. So the question is, you mentioned that there is atmospheric plasmas and plasmas in vacuum. Do people research pressurized plasmas? Very cool question. So, hi, my name is Greg Friedman. I'm a plasma bioengineer. I spent my entire career researching non-equilibrium plasmas. And on this channel, I like to chat about plasma systems in common language, no crazy science, and I really like answering your questions. So if you have a question, please post it down in the comments below. I answer most of them. I'll definitely love to consider making a full video if the question is challenging and within my domain of expertise. So today, let's talk about plasmas, electric discharges, and how they behave at different pressure, different atmospheric conditions. People often talk about lightning, atmospheric pressure plasma occurring in atmospheric pressure, in open air, or low pressure plasmas that are used in microelectronics. However, plasmas are used everywhere. Think of a spark plug in your ICE engine, internal combustion engine. Doesn't apply to electric cars. So piston compresses the gas or vapor of gasoline, compresses it, and then there's a spark. Now that spark occurs at a pressure much higher than atmospheric pressure to ignite the gas and push explode and push the piston back. So that's a high pressure plasma. And it's in your car, and it's firing thousands of times. What's RPM? Like 5,000 RPM. That's 5,000 repetitions per minute. That's 4, 6, or 8 cylinders. So it's a few thousand times a minute that spark fires at high pressure. Generally, low pressure plasmas are used in the industry where high precision and extreme uniformity are required. When you have, like you're making an iPhone, everything needs to fit perfect. Or you're making a microprocessor, everything needs to fit much, much, much perfecter, right? So there are different pressure plasmas that are used in processing of various microelectronics and in manufacturing. Atmospheric pressure is the cheapest. You don't need low pressure vacuum pumps. You don't need any kind of fancy enclosure. And you're able to put your process on a conveyor belt rather than in a batch system where you put your electronics into a vacuum chamber, reduce the pressure. That takes time. And the lower the pressure, the more time it takes, the more expensive the pump is. These pumps, some of them are millions of dollars. So if you can work at a slightly higher pressure, well, the price goes down very much. And most of my career, I did a lot of work on trying to move away from low pressure systems and go into atmospheric pressure for different kinds of surface modification, surface treatment, surface functionalization, all that sort of stuff. Everything that's done in vacuum, I'm trying to move it to atmospheric pressure. Now, plasma, there is so-called Paschen's law or Paschen's curve. Plasma scales with PD, pressure, distance. Literally, if you want to oversimplify it, it's that simple. For atmospheric air conditions, you're talking super dry air, no weird things, no crazy wind. Oversimplified. the distance between two electrodes to ignite plasma is 32,000 volts per centimeter. So for about this much, you need 32,000 volts. Now if you go to 1 millimeter, that's 10 times less, and pressure scales, plasma scales with PD, so distance is 10 times less. Well, the voltage required to ignite the discharge is 10 times less. So at 1 millimeter in atmospheric conditions, it's 3.2 thousand volts. And you can imagine the lower the voltage, the cheaper the system is. So if you're able to functionalize your surface at 1 millimeter, then you're able to go to 3 kilovolt. If you need 1 centimeter of working distance at atmospheric pressure, you need 32,000 volts. Or you can reduce the pressure 10 times. So at the same 1 centimeter, 10 times lower pressure, 32 kilovolts will give you 10 centimeters, not 1. So you're able to process bigger things. What if you want to process at 1 meter distance? At atmospheric pressure, that's 3200 kilovolt. That's 3.2 megavolt. Those are crazy voltages. It gets very complicated going above 100 kilovolts. A lot of protection. You need to protect from hard X-rays, and there's a lot of weird stuff that happens at those really, really high voltages. But if you want to process something that's a meter away, why don't you just go to 1,000 times lower pressure and the same 32 kilovolt, or 100 times, I'm sorry, the same 32 kilovolt instead of centimeter, it'll be per meter. Now the question mentioned pressurized plasmas. Gosh, most of industry runs at higher pressure than atmosphere. If you're wanting to treat gas, modify it somehow, the more gas you can squeeze into the chamber, the more uniform the treatment, the faster you get whatever product you need. A lot of industry works at 30 atmospheres, 30 times higher pressure than what you have in your room. Now, at those super high pressures, again, pressure, distance, 10 times higher pressure, 10 times smaller distance, or 10 times higher voltage. So the same 32 kilovolts isn't going to be per centimeter, but at 10 atmosphere pressure, it will be per millimeter, if that makes any sense. So it's very simple. Plasma is widely used in the industry, both at high pressures, super high pressures, low pressures, super low pressures, and everywhere in between. Focus of my work is to bring those processes to atmospheric pressure, but there's a lot of interesting work, very important work. I don't know if you heard, iPhones or microprocessors for your microelectronics are going to smaller and smaller transistors. I think we're at 3 nanometers now. And at that precision, the pressure to create extreme uniformity, the pressure needs to be very low. And there's a lot of research happening today. There are a lot of things we don't know. What happens at 100 atmospheres? Can we treat very large volume of gas or even liquid at these really high pressures using really advanced plasma systems? Yeah. I mean, at the very least, you're probably going to need master's degree in either mechanical or electrical engineering to work with these systems, but there's a ton of work happening, and it's really cool stuff, and I see new publications come out every day. So, anonymous comment 5722, thank you for your question. I rarely talk about high-pressure plasmas. They're a little bit more rare. Around you live in 1 atmosphere, and most of you know that microelectronics are done at low pressure. But yes, there are high-pressure plasma systems. Again, thank you for your question. I love making these videos, answering your questions. It's very exciting that there is, albeit very small, interest in plasmas, and I'm happy to chat with you about them. leave me a comment with your question, and I'll see you in the next one. Peace.